So this is the last plot from this investigation of Simon's model, this redoing of it. A little bit of fun. So let's look at some real data, and you play around with real data. We looked at, we try to look at the dominant city in countries. That's kind of all over the place, actually, right? There are some cities that really sit off what the zip distribution looks like for the rest of their cities, and they can be bigger and they could be just kind of average. So, there's a lot of history and depends who invaded what and so on. So that is complicated. This is from citation data, which was famously examined by Jasola Price using Simon's model. And there's some meta-ness here, right? So this is the Barabasi-Albert paper that I just mentioned. This is the scale-free networks paper. Again, we'll talk about it later on. They don't use this title scale-free networks in the, they don't use this framing in the title. They write it in the paper, so it's not in the title. But what this is all of the subsequent papers, at least in Web of Science, that have scale-free networks in their title, right? So various ways we could do this. But we took all of those papers and looked at how many citations they had. So the number of citations, this is the number of citations for the Barabasi-Albert paper. It's, at the time this was done, now it's, it's into the tens of thousands, maybe 30 or 40,000 citations, which means you've done pretty well. I mean, it's absurd, right? So if you get into 10,000s, you've probably helped, maybe, depends on the field, but you've maybe started to help start a whole new body of work for sure. So you can see, right, this is the first one that cites it. This is just in order. It's not a time order. It's just in order afterwards. This one didn't do very well, right? But it mentioned scale-free networks. Didn't do very well. But they're all over the place, and some did super well. And if you draw a ridiculous line through the whole thing, and then, check out this this difference, we can estimate the innovation rate, right, which in this case is about a 0.1. And that matches up pretty well with the gap here. This factor should be like 1 over rho. So it's a very simple thing in the end, right? So whatever rho is, whatever the innovation rate is for your system, that's what you expect this. If it's a pure rich get richer mechanism the whole way, that's what you expect the first one to outweigh where it should be. The inversion of that, right? So if your innovation rate is 100th, then it's a factor of 100. So this was a bit of a cheeky one. It worked out pretty well, right? So this is this slope, and these guys are quite nice. So, and it's about the rich get. This paper is about the rich get richer mechanism. Okay.